Okay.
Got trouble. What about all three of you have worked well together? I think you've all been there pretty.
Yes, this is the first. This is the first one where somebody's had to miss.
Okay, good. And you're all working together. Yep. I'm working on an email and I haven't got it done yet, but I'll ask you that in the email again. But
okay.
Okay, I'll just listen up and see if I can pipe in if you need something.
Okay, well, we usually start with a prayer, so I'm going to go ahead and say it tonight. So, Father in heaven, we thank you for this beautiful day and the many blessings that thou hast provided. We thank you for the opportunity we have to be able to attend school with and be in a group with one another. And we ask that the Spirit would please be with us and watch over and protect us. And most especially, please be with Ashley this evening and her family and watch over and protect them and whatever the situation is that they're in. And please be with us as we do our homework this evening, that any questions we may have for Stephanie, they'd come to our minds and we'd be able to ask and receive answers. We love you so much and we're so grateful. And we say this in the name of thy Son, Jesus Christ. Amen.
Amen.
Okay. All right, Vincent. It's just you and me tonight. Well, and our TA. Yay.
Yeah, we got this.
So, did you have any questions on the lesson 7 at all?
Nope.
Okay. I might have some, but I don't have any at the moment. I did go through with the video that is when it talks about the homework, or not the homework, but the preparation, and it has the lesson, like a walkthrough on how to do the questions. It's actually really cool. So, if, yeah, I would definitely say use it. So,
yep.
All right. Do you want to go ahead and
it's an exam next week?
I think so. I haven't looked.
I think it is next week.
Yeah.
That lesson 8, it's really long, but it's the review for the test.
Okay.
And the test will be, so you'll have the review and then you'll have the test. And I think you still have lesson 9 at the end of that.
Okay. Yeah, I see it on there.
End of the week, yeah. I haven't looked at dates on the test yet, but
okay. Well, the test be
I don't know what happened. My computer is like freeze right now.
Did it freeze? Maybe give it a minute. Okay, so it's showing that exam 12 p.m. So it looks like it's open like right now for you.
Oh, okay.
And then it will close the 12th, which is Wednesday night at 11:55.
Oh, okay.
You can't go in and dabble a little bit and come back out. You have to just take it in one time.
Okay, and you said it's timed, right?
It is, but I think it's like 4 hours or something.
Okay.
I've never seen anybody take that long.
So that's why you're saying, like on lesson, lesson 8, we'll go over that on Tuesday, and then we'll have to do the exam by Wednesday, right?
Wednesday night, yeah. So maybe maybe you're better off to go ahead and meet on Monday, which gives you all 3 of you Tuesday and Wednesday to take the test, and just text me if you have questions and need me. I'll give you my text number. I'm trying to find the time limit on that, but because when I open it, it's different than you guys, and I can't. Oh, right. Right here. Maybe this will tell me.
Vincent, are you still there?
Yeah, I'm still there.
Okay. Yeah, your screen is frozen, but we can hear you, so that's good.
Okay, so it says 240 minutes, so that's 4 hours.
Okay.
And I've really truly never seen anybody take that long. I think it'll be fine.
Okay.
This is the first one. You do get to have a page of notes. So if there's something that you've done, formulas, make sure your formulas are written down. So this is like one sheet of paper, one-sided.
Okay.
Write down formulas. What I would do is I went to each lesson, and at the bottom, there's a summary or things to remember or something like that down at the very bottom.
Mhm.
I always reviewed that to make sure I had what I needed out of that. So you can trying to get into my own group 7 thing so I can look at the answers while you're going through. Okay.
Okay.
Can you see me now?
Yes.
Okay, I'm using my cell phone.
Oh no.
Like my computer won't load. I don't know why.
Oh.
Hmm.
Okay. So, did you hear everything that you need to have for the exam that's due on Wednesday?
I heard that like the last part that I got was like we can have a note and like with our formulas that we have,
Uh-huh.
and
Yeah,
that's and then I lost it.
Okay, and she said also that you can go, when we're in the reading material at the very bottom, it has things to remember. That'd be a good review to go over also.
Okay.
Go
Okay.
back and look at your group quizzes. I
Okay.
think you can look at those. You just need to just look through everything. The first test is supposedly the easiest, so bum me
So
out
do
there,
the tests build on each other, or do they?
yes,
or is
because
it like
this whole class basically builds
okay?
everything, and so you really have to know the beginning to work in the middle. So
Okay.
it's not. I don't want to say that. It basically is. They all build on each other. So if you understand it, you'll be all right.
Okay.
And the other thing that I will tell you is after the exam, make an appointment with me or Brother Polson to go over your exam.
Okay.
Because the people that have done that have done a lot better. They feel better about what went on. They understand what they got wrong. And because it continues to build, they understand why they got it wrong. So
Okay.
sometime after the test closes, you have to wait till it closes. Get a hold of me and we'll go through your exam.
Okay.
So
I think I'll definitely be doing that because I told my group last week that I haven't taken math since I probably took college algebra,
yeah.
and so and that's been like over 10 years now. So
I would. This is more concepts than math, really. I mean, there
Okay.
is some math, but really, your concepts are the harder thing than the math itself.
Okay.
So I wouldn't put your pressure on yourself for that at all. Have you found it to be hard, the math part of it?
No, not the math part, because it's really just like adding,
Good.
subtracting, multiply, divide. And I guess it's really with remembering the theorems and like especially this week, like the difference between the central limit theorem and the
Law of large numbers.
Law of large numbers. Yeah.
Yeah, I still don't remember this, and this is I took it in the fall. I was a TA spring, winter, spring, and I'm a TA again. So this is my fourth time through.
So they just canceled.
Uh-huh.
So I have to get it all in my head.
Okay.
Okay. Anyway, that's what I try to be here for, is to give you tips and things to help you.
Okay.
So, shush up now.
Thank you so much for your time.
Yeah, I appreciate it. You answering questions and stuff like that. So, all right, Vincent, you ready to start with the lesson, or is there any questions on part 2? On the
not right now. Like so far, like I followed the video and it really helped. Like the video.
Yeah, it seemed like it really built on what we did on Monday too. So
yeah.
Okay.
So, okay,
and last week.
I just reboot my computer and I'm logging into Island. Just a second.
Okay.
Okay, got it.
All right.
So 15 questions.
Oh, hold on, I haven't got there yet. All right, here we go.
Okay, you want to take turn reading again?
Sure.
Okay. I can go first. Use the
Alright.
normal probability applet to find the combined area under the standard normal curve that is to the right of z equals 1.358 and the left of z equal to minus 1.358. Okay. So 1.535.
So is that what it say? It says the combined area, so would we do the whole curve then?
Yes.
Well, it's always going to be 1, but
Yeah. So is it
Find the
just one?
the combined area under the student. Oh wait, it's to the right. It says to the right of the z and to the left, so I think maybe it's the to like make the left to the left of the red line blue and the right of the red line blue. So it'd be 0.175. That makes sense?
So just leave the middle like empty, just like
Yeah.
the left and the right.
I think so.
So I got 0.175.
Yes.
Okay. Okay, perfect. So that's what I got. So is it rounded to like 3 decimal plate?
Mm-hmm.
Okay.
Practice like apologize a little bit.
Perfect.
All right, so number 4.
Actually, just finished my homework, so I'm pretty good.
Which of the following will have a smaller standard deviation? If 9 observations are randomly drawn from a population. Okay.
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 So which of the following have a smaller?
We can skip that one and come back to it if you want. I'm not really sure. So
Let me see.
I'm not.
Yeah, like I don't know how to calculate that.
Uh,
It's not really a calculation. You have to just think about what it's asking. One thing I would do is pull up your applet.
okay.
It's not gonna, the applet's not gonna be the answer, but it's gonna help you picture it. So it's asking you about individual answers, right? So
Right.
you could get one here and here. Oh, I'm not sharing. Oh yeah, I am. Okay. So let me get my little handy dandy snipping tool so I can mark on here.
Okay.
Okay. So you can get a sample here and a sample here and a sample here and a sample here and another one here and another one way over here and another one right here. So there's the standard deviation of all these.
Mm-hmm.
So that's how far the average distance is between each one, right?
Right.
How far they are from each other. So when you have a sample, your sample means, are they going to be that widespread? Probably. or are they going to be closer to the mean?
They're closer to the mean.
Because that's the I gotta word it the right way. I gotta stop sharing because it'll show you all the answers.
Oh, okay. Darn it.
I know. I learned this the hard way.
I don't mind
So-
that actually.
I know. So your individual observations are going to be all over the place.
Okay.
Mean is going to be more average. You
Okay.
see how I'm trying to make sure you understand the why. I'm kind of like giving you the answer, but that's the why of it, because the sample means it's the mean, and so they're going to be more compact right there, and so the standard deviation isn't going to be as far out as the other.
Okay. So it's the distribution of the sample means.
Yeah.
So does that go back to the in lesson 6 where we had that little pop out thing where it had the 4 different graphs and you tested to take out
You dropped all those
you
things.
dropped them down? Yes.
Yeah, exactly.
Okay.
Yeah. Yep. Perfect.
All right. That
Okay.
makes sense then.
Number 4 is right too, by the way.
And what was that about number 4?
That's right.
Okay. All right. Number 5, Vincent.
Okay, number 5. Which of the following result implies that the spread in X? This one is decreases
It's X bar. is
X
what-
bar.
bar as the sample size increases.
Okay. Well, I don't think it's the central limit theorem.
Is it the 68, 95, 99.7% rule?
Mm,
Decrease as the sample size increase.
sample size decreases.
What is the X? What's that
X-
called again?
X bar.
X bar mean? Again?
I don't know, it's kind of just a value, I guess, that
So
You're trying
that is your X bar is your sample mean. So let me share again. Let me show you something. So somewhere in here,
excuse me.
there's a symbols reference page. So X
Oh,
is the sample mean. Mu is the population mean. Sigma is the population standard deviation. So these kind of things are going to come up a lot. And so so I don't know how far down your test is going to cover, but if you've seen it before, you probably ought to write it down if you don't have it in your head.
okay.
Okay.
But X bar is the sample mean. And so it's the average of the sample that you've taken.
Okay.
And that's in that Z-score formula. That Z-score formula that is X
And
bar
this,
minus mu. Sorry, it's a bad mu. Sigma over the square root of n. So those things are in here. You'll use this a whole lot. So
okay. I wonder if it'll be the normal distribution then, is the answer for
Yeah.
5.
No.
No, it's not.
What about
Okay.
the 68, 95, 99.7% rule?
what does that rule tell you?
That it'll either be 1.
68.
1 standard deviation, 2 standard
2
deviations.
standard deviations, 3 standard deviations.
So is that what it's asking you?
No.
Is that okay? So that's probably not the right answer either.
All right.
What is
Over
that?
on the meat saw.
It's not any good. It's not any good.
Well, then they
Be
better dump
quiet.
So I guess it's the
Okay, so
large
it's either
of large
the law of
number.
large numbers.
it.
So why? So that's what the law of large numbers is. Is it's saying that the more numbers you have in your sample, the closer that mean is going to be to the population mean.
Okay.
Okay.
So that goes back again to that. Hold on a second. What? It's laid out on the bed, and so is another shirt. There should be a pair of pants in it. Okay, sorry. The more. Okay, just take it as that, because your sample mean, each time you get a sample mean, the bigger the sample is, the closer it's going to be to the middle.
Okay.
Okay.
Other mean. So a little confusion further. We'll call that good.
Okay.
I'm just glad you're here because yeah, we totally would have got that one wrong. And it helps explain it because I understood it when we were talking about the central limit theorem because it seems like that's what we focused on more on lesson 6. But I wasn't really sure about how it worked with the law of large numbers.
So I would go back to wherever those are, because see,
Okay.
those aren't right in your head. I would write those down on your sheet of notes.
Okay.
So that's what I did when I took the class. I had a piece of paper in my notebook, and that was my notes. And as I went through each lesson, I would write down the things that would snag, and
Okay.
things that weren't settling right, I would write them down. So that's how I did it.
All right, Vincent. Number 6. Use the following info to answer the next 4 questions. Scores on the quantitative portion of the GRE are approximately normally distributed, which means I can't remember the name of that symbol. Equals 150 mu. Yeah. Equals 150.8 and standard deviation is 8.8. Okay, so Diane earned a score of 160 on the quantitative portion of the GRE. What is the z-score corresponding to Diane's score? Okay. Calculator. Okay, you got it?
Not yet.
Okay.
What is the equation again?
This is where you take whatever number
Minus.
they're asked minus the mu divided by the standard
The
deviation.
standard deviation.
Yep.
Let me pull up Excel real quick, just a second.
Okay.
I don't know what happened to my computer. I got 1.045.
That's what I got.
Okay, next question. What is the probability that a random selected student will score above 160 on the
Quantitative.
quantitative
Uh-huh.
portion of the GRE? So do I just use the same formula?
Well, I wonder, is that where that where the applet gets used?
So we put in 1.045.
Uh-huh.
1.04 and minus 1.045.
Yeah.
1.045. And then it has to be above. So
Yes, above the 160. Yeah.
so it's like here. Can you see it? Oops. Like that?
Yeah, that's what I did. That's what I did.
I got 0.148.
That's what I got.
Okay. Question 8.
Wait, one more. Okay. A random sample of 5 students was selected to take the GRE. Their scores are 160, 175, 163, 149, and 153. What is the z-score corresponding to the sample of these students' scores? Sorry, what is the z-score corresponding to the sample mean of these students' scores?
So do we use the Excel and put in the number in it?
I normally use my calculator.
So just calculate the mean of those numbers?
You can calculate the mean either way with your calculator or with that applet, either one.
Okay. I got 160.
Oh, hold on. All right. Hold on. I did my math wrong.
Is 160 the right answer?
Well, that's not what it's asking. It's asking about the z-score. So now you have to find the z-score.
Oh, okay.
So on this one, I just want to make sure I understand it. Is this where you're going to take each of those values? So like the ones, no, never mind. I just answered my question. Okay. We find the mean of this and then insert it into that,
Area, like the output.
well, it's either that or the z equals value minus mean divided by standard deviation.
Yep.
Oh.
Okay.
So your mean, I didn't do it. I mean, I did it when I did the test, but I didn't keep it. Yeah, the mean is 160. That part's correct. So now you put that into the z-score, into the z-score formula.
Okay. Okay.
So z-score equals to the number minus mean divided by standard deviation. But like, what is the number? Minus
Divided by the standard deviation over what?
The square root of n.
Correct.
But okay. So the value is the where we go back to the information, and that'd be 150.8
Yeah.
minus the
160.
divided by 8.8 divided by the square root of
You've got your sample mean minus your population mean. Which one's your sample?
150.8.
Not your population mean.
The 160.
160
160.
minus.
Do I have the
150.
numbers backwards?
You did, because the
Okay.
X bar is your sample mean and the mu is your population mean.
Okay, so it's all right. So it's x bar minus the mu divided by.
So it's 160 minus 150.8 divided by 8.8.
Divided by the square root of
8.8.
How many are in your sample?
5.
Yeah.
Okay.
talking to somebody?
Yeah, I'm in a meeting.
Are we gonna go tonight?
Yeah,
At what time?
8.
8 or 8:30?
Let's do 8:30.
8:30?
Yeah.
Okay. Is Cayenne coming over? Or are we gonna pick her up?
We can go pick her up.
Okay, I think I have it.
I'm sorry. So the square root, is it like of the samples, like the numbers of
Of the
sample?
sample, the sample size, yep.
So square root of number 5. So 2.236.
Yes.
2 point what?
2.338.
That's not what I heard him say. What did you say, Vincent?
2.236.
Oh,
You
I
got
I'm
something-
sorry. I got 2.338.
So let me tell you I don't know. So
So did you do? Go ahead.
what did I do was 160 minus 150.8,
Uh-huh.
and then divided by the square root of 5.
Okay, so on this one, on the formula, there's more to the formula there was previously. And so it's the 160 minus 150.8 divided by 8.8 divided by the square root of 5.
So I have divided by 8.8 first. And then,
Well, and 8.8 divided by the square root of 5 is also a, sorry, I don't know how to explain it without showing it to you.
So if you do those in the wrong, so you can't take 160 minus, so what would that be, like 9.8? I mean 9.2?
Yes, 9.2.
You can't take that and divide it by 8.8 and then divide by the square root of 5. You have to take that 8.8, divide it by the square root of 5, and like save it in your calculator in the memory. Come back, do your numerator, and then divide it by what you have in your memory. Because
Okay.
it's the order of operations thing. You can't do it out of order. Wait, just a second. Kobe.
okay, now I got 2.337.
Okay, that's correct.
2.338.
Yes. Good job, Vincent. All right.
Question
Okay, I had to-
9.
So did you get the same answer, Vincent?
Yes.
Okay, all right.
Question 9. What is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the student in the previous problem?
Okay. All right, let me look at this. Score greater than the mean. Okay, Sister Kunstler, is this where you would put it into the applet?
Okay, So
Or do you have to go do that?
talking with somebody else. So
Okay.
what did you get for number 8?
2.338.
For number 8?
Oh, sorry. Just kidding.
Okay,
Yes,
sorry.
2.338.
Okay. That for number 8. Oh, okay. My questions are one off. I forget that.
Oh, okay.
Questions are one off, and I'm like, that's number 9. How did I do that to them? Oh my goodness. Okay. Oh, okay. I always forget that my numbers are off because I have some extra question or something, and it makes them off.
Uh-huh.
What did you get for 7?
Yeah,
Okay,
that's what I got.
cut out a little bit. What was 7?
0.148.
Okay. All right. We're good. Okay. 8 is the 2.338. We're good there.
Right.
So number
Okay.
10. What is the the probability? So you take the z-score that you found in the previous problem and put it into the app to get the probability.
Okay.
And this one is one of those
And then-
ones that you've got to watch and read because this one says round your answer to 4 decimal places.
Okay.
So beware of that one.
All right. Okay, so what greater than the mean achieved by the students in the previous problem? So you put it in there, the 2.338, and so it would be 0.0097
Yes.
because it's the stuff above the red bar.
That's the only little portion that's, yep, that side of the bar.
Like just
Yeah, I'm just
that
now
little
starting to
one?
figure out where to read on that.
Yeah.
Oh.
You'll get lots of practice.
Oh,
You got to talk, Vincent. I can't see it.
I got 0.0097.
Yes. That is what I have as well.
Okay.
Okay. Number 10.
Suppose the mean GPA of BYU Idaho student is 3.5, and the standard deviation is 0.7. It is well known that this distribution is left scribe. A random sample was n equal 81. Students will be drawn. What is the shape of the sample distribution of the random variable x
X bar.
which represents
So
the
there's a little
sample mean
bar up above, X bar. So just look at the
X
little
bar.
bar above, X bar.
x bar, which represents the sample means of the 81 students who are selected. So it will be also left skewed,
Skewed.
left skewed.
I think so.
Because like on
Tell me
the,
why.
no,
Huh?
I said, tell me why.
so at the beginning, from the information they said it is well known that the distribution is left skewed. No,
That's what it says. But
it has a sample size larger than 40 or it has a larger sample size. So even though it says it's a left skewed sample, it's going to be approximately normal because it has a larger sample size.
Oh, is it? If it is larger than 40, it's going to be normal.
Well, I can't remember the bottom number. I'd have to go back and look in the book.
Larger than
What
30.
was that?
Okay, I said larger than
Larger
30.
than 30, yeah.
So what
Yeah.
are you seeing on your screen for me sharing?
Are
Are you seeing a probability applet with no marks? Are you seeing my marks in the formula?
We're seeing the marks in the formula.
Okay. I have two screens going so I can do this. So
Okay.
So that distribution is going to be it's going to look more like this. And so most of your values are going to be over here.
Mm-hmm.
But when you take a sample over 30, that's your averages. That's these little things that we were talking about right here.
Okay.
And so that makes them look more like this because you have a bigger sample. So all your sample means are going to be this here in the middle.
Okay.
If it's less than 30, it doesn't have enough.
It doesn't have enough samples.
Right. And so it moves it over to the left.
Right.
Because you have more
Or correct.
over there. Yeah.
Okay.
So you have to watch what your problems say as far as left, right, and is there enough to make it not skewed anymore?
Okay. So that would be approximately normal then.
Yeah.
Okay.
Because you have a sample size large enough to make your sample mean normally distributed.
Okay. All right. Question 11.
So lots of vocabulary.
Yes, yeah, definitely a lot. Okay, number 11. What is the mean of the distribution of the sample means for all possible samples of size 81 that could be drawn from the parent population? Okay.
What is the parents population?
I believe it's 81.
The parent population is the It's the population rather than the sample. I mean, yeah. So for this, the population would be all students at BYUI.
Vincent, did you set up the formula?
Yeah.
Okay.
So it's equal like to the 81 minus the mean.
Okay, let me find where to point you guys. Just a second. Go to number 4 on lesson 6. In your book, number 4. In your book, number 4 on lesson 6.
Okay. Okay.
It's gonna freeze here, so the kids have got to cover the garden.
Oh my goodness. And you're in Idaho, right?
Yeah, I'm just a couple hours from Rexburg. Rexburg's probably already frozen. They're a little colder than I am, I think.
Wow, and it was like 90 degrees here today.
Oh my.
Okay.
For Texas?
Yes, I'm from Texas.
Where do you live?
I live about 45 minutes northwest of Austin.
Yeah, Texas. Okay. Gotcha.
In the hill country. So.
Do you know where Texarkana is?
Yes, I do.
That's where I grew up.
Oh, nice.
Yeah. So yeah.
I work in a property management company, and we have a property in Hooks, which is right there next to it. So yep.
Okay.
Very cool.
Get to section 4 in the book.
Yes. It's
So is that the answer?
Yes, sigma divided by the square root of n.
So that's wanting the mean. It's not wanting the standard deviation.
Oh.
Your problem says, what is the mean of the distribution of the sample means?
Oh, 3.5.
Yep.
Yeah.
Did you find it?
Huh?
I was wondering if Vincent found it.
Yeah. Vincent, are you there?
Yeah, is it like the mean and standard deviation of the distribution of sample means?
Yes, that's the section. The mean standard deviation of the distribution of sample means. That's the section. And it says the following facts are always true. They don't depend on the sample size. There's your answer right there. So these 2 little sentences right here, you might want to write down for your note.
Lesson 6.
Yep, lesson 6, section 4. These are just
I struggle with
things that you've got to.
Yeah.
You'll get it. It just takes a little time.
I struggle with reading too much into it. Like that question, actually, now that you go back and look at the question, is super easy. But I'm like, oh, okay, we have to do this math problem.
Mm-hmm.
Okay. Vincent, did you get number 11?
Not yet.
Okay, so go back to the question. And so think about the lesson 6, section 4, but it says, what is the mean of the distribution of the sample means? And so go back to the information we were given. There's nothing that we need to, a number minus anything. We just have to give what the mean is.
Oh, so just the mean is 3.5.
Yes. We were making it super complicated and it was really easy.
Oh, I was like using a formula, like starting to calculate.
I did it too, so don't feel bad. I did that too.
Okay. Okay, question 12. Man, that one is tricky.
Yeah.
I didn't think that it's going to be that easy.
Well, if you think about the preparation, some of the questions were like that in the preparation too. So,
Oh.
yeah. All right. So what is this? Okay, this one could be tricky too. But what is the standard deviation of the distribution of the sample means for all possible samples of size 81 that could be drawn from the parent population?
0.7?
Yes. I would agree with you.
You need 3 decimal places though.
0.700.
Oh, this was not quite as easy. Go look back at that formula.
Just kidding.
Oh, man.
The second line. So the first line says the mean of the sample means is mu. And the standard deviation of the sample means is,
Oh, hold on, I missed it.
okay, so let me explain this a little bit.
Okay.
So the mean of the sample means, and so you take a sample of 81, like you dropped all those little blocks,
Uh-huh.
you have a sample of 81 and you get that mean, and you have another sample of 81 and you get that mean. Those aren't going to be the same because you have numbers in that sample. You have another sample and that has its own mean. So the mean of the sample means is an average of all those.
Okay.
An average of all those averages is going to be the same mu. So I don't want you to get in your head that the sample means is the same, because it's not. The mean of all your averages. Okay?
Okay.
So then your standard deviation of your population is sigma, but the sample
Divided by the square,
is square root of n. Yeah.
that's 0.556 then.
It's what?
Oh, wait. I take that back. Hold on.
So Vincent, what are you supposed to do? So what's sigma?
Sigma.
What number is sigma in this problem?
81.
81 is n. That's your sample size. What's sigma?
Is sigma the standard deviation?
Correct.
Deviation?
Right.
0.7.
Correct. So in that formula, what do you have? Sigma divided by the square root of n, which is what's n?
81.
Right. So it's 0.7 divided by the square root of 81.
So that's mean 9.
Yep, that's 9. So it's 0.7 divided by 9.
That will be 0.078.
Correct. Correct.
Oh, why is this so difficult? Like when
Hey,
I
we're
was,
going to remember this.
I was doing the exercise following the video, I think I got it. But like every time when I do this, I just don't understand.
So you might
Yeah.
want to go watch the videos again before the test.
Okay.
So
Okay.
because now that you've worked with a few things and you go back and you watch that first video again, you go, oh, okay, this ties in here. Okay. And then you watch the next video. Okay, now I get it. You know, it'll help if you go back and watch the videos again.
Okay.
Well, and since you told us where that the symbols reference pages, that's really helpful too to know what those are also.
Okay.
Okay, number 13.
Oh, I thought we do number 13. Oh, just kidding.
No, number 12. We're almost there though. Okay, what is the probability that the mean GPA for 81 randomly selected BYU Idaho students will be less than 3.3?
So use the applet.
You will eventually, yeah.
Well, you have to do that equation and then put it in the applet.
Correct.
So we need to find like this z score.
Correct.
Yes.
So z score is equals to 3.3 minus the mean divided by the standard deviation.
We have to do the 0.7 divided by the square root of 81.
Yes.
I'm sorry, can you repeat that one more time?
You have to do it the point. You had it correct on the top. 3.3 minus 3.5 divided by 0.7 divided by the square root of 81.
And is this how you calculate the z score?
Correct.
But like, how come before we don't have to divide the square root of the number? We just divide it by the standard deviation.
I think because this is because you're getting it of a sample.
Oh, of the 80 from the 81, not
Yes, from the 81. Yes, yes.
So let me do this in a way that you can understand. So when you know how you've done the test, you know, so and so got such and such on the test. That's one sample, and so really that standard deviation was sigma divided by the square root of 1. And so they just teach you without that square root of 1, which kind of it does confuse students a lot. I've seen this a lot. They don't understand when to use the square root of n and when not to. But you're really using it all the time. But those first few problems, it's one test. It's one whatever. So you're over the square root of 1.
Okay.
So you're really using it all the time. So this one, n is 81 instead of 1. And so you have to put a number in that square root of 1 of n.
Gotcha.
That help a little bit? That's something that's confused a lot of people. Well, in fact, that's what I missed out on my first test because I didn't catch that it was 2 different formulas and that there was a square root of n. And so I didn't write that down, and so I got problems wrong because I didn't have the square root of n under one of my problems.
I got minus 2 point. Oh, not yet. That's just like it's just the c score.
Right,
So
but you got 2.744?
Yes.
Okay.
What do you get?
2.744.
For the c score?
Uh-huh.
I got minus 2.57.
Let me check my math real quick.
So on the top, I use 3.3 minus 3.5.
Right. So that's negative 0.2
0.2 divided by 0.07777.
So one of the things that I'll tell you if you have like a z-score and a problem before, it's better to use an unrounded z-score. Z-score. No, not z-score. Sorry. The denominator of this formula, the standard deviation.
Mm-hmm.
Because once you round it, it kind of changes things sometimes. Vincent, what was your z-score? You said 2 point what?
The z-score.
Yeah.
I got minus 2.57. Negative 2.57.
I got negative 2.597.
Oh, I know why. Okay. So I have both sides of the thing. Okay, we're good. 2.57, that gets you the right answer.
Oh.
I had both in shaded instead of one.
Okay. So that's 2.57.
So how come we have different answers?
I did my math wrong.
Okay.
It's when I divided the 0.7 divided by the square root of 81.
Has to be greater 3.3. So it has to be larger than the red spot. So I got 0.0051.
Hold on.
0 what? 0 point.
0051.
Your thing is less than 3.3.
Yeah.
But that's still the right answer.
This is
0.0051.
Yeah. Well, don't put the 1 in there. 0.005 rounded to 3.
Rounded to 3.
Yeah.
Good job, Vincent.
Oh, thank you.
Hey, now the next problem's really hard. What do you have to do the next problem?
Oh. Shade it above that.
You have
Correct.
to,
That's all you
Yeah.
have to do. Because all the information's the same. They just want to know the other half of the applet. So you
And I remember that in
change the other two.
the video.
Yeah.
Yeah, because he said, "Oh, all you do is just this is this, and you're gonna flip this, and it's the same." So.
Yep. Yep. So make sure you type this answer right, because I got goofy and did it wrong, and it really ticked me off when I was in class. It's
Don't put
funny
the
as I
one
go through these, I'm like, oh, I remember missing this one. So tell me your answer for 14.
0.005.
Okay, that's 14. 15. No, let's see. I gotta figure out my answer. My numbers. Okay, 13 was
0.005.
and 14 is.
The same thing.
Okay, it's not the same because it's greater than 3.3. So you use the same. Let me show you on my applet.
Okay.
Somebody get the phone. I don't think anybody's in here. Okay, so
Oh.
less than I can't. Okay, so this is the answer to 13. So it wants, this is less than 3.3. Now they want to know greater than 3.3.
oh, so it should including the
You
middle
don't
part.
want that. You want
Yeah.
everything else.
Everything else. So it's
Correct.
0.995.
995.
Right. Yeah. So this area, this is one of those things where everything under this applet has to equal 1. And so if less than 3.3 is 0.005, everything else has to equal
The rest of that.
plus
to equal
1. It equals 1. Yep.
Yeah, I have to do better about reading it more carefully.
I
'Cause
hope
that's what'll get me in trouble.
Okay, I don't know. It said I was sharing and then it said I wasn't, so I don't know what happened. Okay, how do
I
I
think you're frozen now, so. Okay, Vincent, number 15, last one.
Man, this is long. The United States Coast Guard assumes the mean weight of passenger in commercial boat is 185 pounds. The previous value was lower, but was raised after a tragic, tra-
Tragic.
tragic boating accident. The standard deviation of passenger weight is 26.7 pounds. The weight of a random sample of 48 commercial boat passengers was recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean, than was observed in this sample.
Oh, yeah.
So it has to be more extreme, which means like it's higher than the standard deviation.
Well, it says no, as extreme or more extreme means that we are not only interested in values that are lower than the ones we observed, but also values that are as far away from the mean as ours in the positive direction.
So right now the standard deviation is 26.7.
Yeah, 26.7, correct?
So the scripture of choice.
Okay.
So what formula are we using this time?
Sorry, let me read it again real fast. Units Coast Guard assumes the weight of passengers in commercial boats is 185.
The scripture of choice is Matthew 16:25.
Okay, so we have the two means. I think we're going to use that same formula we've been using. The x bar minus. Divided by sigma divided by
48 square root of 48.
Yeah.
But whosoever shall lose his life, my kid shall find it. Kind of what I wrote about it is I kind of compared it to how like basically throughout my mission we were always told to remember our why, quote unquote. Just remember our reason for why we're out in missionary, like why we took the mission. And then my mission president's 5 pillars thing that I talked about my homecoming.
So I got 185 minus 177.6 divided by the standard deviation divided by the square root of 48.
You're close.
Mhm.
Did I put it backward? 177 point. I don't know what to put first.
That gets me every time too.
Okay, so you have to go back to that references page. X bar is the sample mean. And so if you remember that, then you'll know where it says sample mean is determined to be 177. And so
Okay.
your mu is your population. That's the mean of all the passengers in commercial boats. They're saying the average passenger of everybody is 185.
Oh, okay. Got
The
it.
sample that they took, that mean is the 177.6.
Okay.
Found like kind of like relating the scripture.
So tell me your Z score when you get your Z score.
Okay. Are they asking for the Z score?
No, just double checking as you go along.
Missionaries were called to represent Jesus Christ, like, represent for his sake.
Okay, I got it.
Losing ourselves in the service of others, that's when we truly find who we are. Things like that. So I was kind of just thinking like that's how I changed so much is because I focused a lot on uplifting other people, inspiring other people, and basically doing everything I could to, work hard out of love, and just do everything for the right reason, to where I was able to
Oh, this is cool.
grow as a person and become who I am right now. So that's what that was my take on the scripture.
Okay, Vincent, you got it?
I got negative 1.92017.
That's what I got.
Yep. Yep.
The thing that came to mind, any ideas?
What's your next step?
Put it in the applet.
Put it in the applet for the C4.
Z4 in the applet for the you get the probability out of it.
Okay, and it's asking the weight is extreme or more extreme, above or below the mean.
I got
It's like me saying, like, what's on my
0.0549.
mission?
Wait, what?
Yeah, I always do what I can.
Because like the extreme,
Not say that.
which mean like it's super heavy or super light.
When I was down there.
So I got like the
I don't know. Like,
But wouldn't
the,
you have? Wouldn't you put the other part above the red bar also because it wants to know extreme or more extreme? Above or oh, I see. Either above or below the mean. Okay.
yourself. Save his life or to lose his life.
Okay, so you're saying it's 0.9451?
Another one of your friends.
I got 0.0549.
Did you finish that other one or did you give it back? Good.
Okay, I'm not seeing how you got that.
Share screen. Let me see your output.
Yeah. Oh.
Because it's greater than and less than.
Yeah.
Is it? Am I doing it right?
Yeah, your answer
Okay.
is right. I just needed to get her there.
Okay, I'm seeing it now. 0.54.
Yes.
Wait.
I'm just trying to multitask typing and listening. So
That'd be 0.055.
Yes.
I'm like, wait.
Okay.
So it's just. Anyway,
Okay, let's submit it.
So like, basically you're saying.
Man, Stephanie, I wish you can come every time. You helped me a lot. Like,
You
Well,
helped me
that's why I
also.
wanted to try and get you to get to that group, the lesson 8. But I'd rather you.
watch the video.
Well, no, I don't usually do meetings on Monday nights.
Uh,
And
Yeah.
so I have to decide whether to do meetings on Monday night or I really don't want to make you wait until Tuesday.
Tuesday.
Yeah.
Yeah, and I don't know when Ashley will be back either.
So why don't you ask her when, I don't know. Okay, so tell me, are you a test taker as soon as you can take it, or are you a test taker at the very last minute?
I can be both.
I think I'm the very last minute.
Your last minute. Okay. So that's the problem. See, we could do lesson 8 tomorrow or Saturday, but if he's not going to take the test till Wednesday, then he'll forget a lot of it.
Right.
So Monday, Tuesday is probably better to do it then.
Okay. Well, I'll
So-
email Ashley and then let you know.
Yeah, you guys decide when and if I can come. And then, oh, my phone. Here's my. Wait, can you see the chat in there?
Like, it doesn't
Yes.
you feeding me stuff.
I do it in a way you can read them. And I didn't do it again. Just a sec. Okay, there's my phone number.
Okay.
You can text me if you have a problem. I probably won't answer a phone call. So,
Okay.
so text me and then we'll see if we can answer your question quick.
Okay. And you said that if we decide to do our meeting on Tuesday, that you could be available to come to the meeting with us?
I will be available for that for you at 6:30.
Okay. On Tuesday. Okay.
Yeah.
All right. Well,
I have another one at 7:30, but
Okay.
we'll do what we can.
Okay. Well, Vincent, we'll talk to Ashley and see
So the way that review is
what
supposed
works
to
best.
is you're supposed to do the review by yourself first, and then
Okay.
you do your second submission with your group.
Okay.
Okay, so each of you need to take it first, and then all come together and compare and go through, and you turn it in a second time with your group.
When we do our homework or the class group work or
Right.
the exam.
When you do the group meeting.
Oh, okay.
So you do it first by yourself, and then you do it a second time with your group together.
Okay.
And so you've
Okay.
each taken it, and you've each gotten some right, some wrong, and you should be able to compare answers and make it a little quicker.
I bought more eggs.
Okay.
You
That
should be.
makes sense.
If you all get it right, you don't need to discuss that problem. You just put your same answer and move on. You
Okay.
might write down your answers, by the way, so that you don't have to do it all over again. Because I don't.
Okay.
I think it's true, though. There's like this.
I myself don't know how to tell you to get in there to look, but I think you can get in and look at your attempt. But if you're trying to do another attempt, I don't know if you can look at it at the same time.
Okay.
But write down your
Okay.
answers and then compare answers, and then we can discuss the ones that you don't get right,
All right. Thank you.
or don't understand. Okay, you're welcome.
All right.
Okay.
See you guys.
Thank
Good
you so
night.
much.
You're welcome.
night.
Okay.
Bye.
Bye-bye.
If they were seeking for the kingdom of God, or for the treasures of heaven,